Welcome to this lecture in the data transformation or data processing module. In the previous lecture, we have gone through basic aggregations after group by. In this lecture, we'll dive deeper into advanced aggregations using the agg method on top of group by. This allows us to perform multiple aggregations simultaneously and customize how the results are presented, making it easier to derive meaningful insights. As seen in the previous lecture, the agg method enables us to apply multiple aggregation functions to group data. Unlike basic aggregation methods like sum or mean, agg offers the ability to calculate multiple metrics for the same group. Also, it gives us the flexibility to rename the resulting columns for better clarity. This is the very important feature which agg brings onto the table. Also, when it comes to agg, it provides us the option to define custom aggregation functions. Let us start by calculating the total and average sale amount for each car model. We'll use the agg method to perform both aggregations at the same time. The logic will look like this. First, let me create a data frame by name Toyota sales data. Then I should be able to say aggregations equal to Toyota sales data dot group by, then car underscore model. The field based on which I wanted to aggregate is nothing but sale underscore amount. Then I have to say agg. Here I should be able to pass a list. The first one will be sum, which will facilitate us to get the total sale amount. Then the second one is nothing but mean, which will facilitate us to get the average sale amount. Now let me run this. This ran successfully. Let me say aggregations dot head. You can see the first 5 records from the data frame. Actually, we have only 6 car models, hence let me run it directly without head. You can see all 6 models along with total as well as average. When it comes to the agg method, it allows us to calculate both the total and average sale amount for each car model. The result is a data frame with both metrics, and you can see the outcome here. Car underscore model is index column for this data frame. This data frame have only 2 columns. They are nothing but sum and mean. By default, agg method uses the names of the aggregation functions as column headers. However, these names doesn't make much of a sense. To make the results cleaner, we can rename these columns using a dictionary. Let me walk you through with an example. In this case, let me actually copy this. Let me paste here. Now here, instead of passing list, we have to pass dictionary. Either you have to create a dictionary variable and then specify the dictionary variable as a parameter or argument while invoking agg like this, or you should be able to use keyword arguments. First, let me walk you through the details using dictionary, then I'll actually switch to keyword arguments. Here, let me say renamed columns equal to this will be of type dictionary. Here, the key of the attributes should be the actual names you wanted to see. The values should be the functions which you wanted to use. So in this case, I should be able to say total underscore sales. Here, total underscore sales will be the column name for sum. The function which we are supposed to use is nothing but sum. In the similar manner, we will be defining average sales as the column name. The function which we are going to use is nothing but mean. Let me say total underscore sales here. Now I should be able to say star renamed columns. Now let me run this. You can see the outcome as per the expectations. Instead of sum and mean, it is actually saying total sales and average sales. These are much better readable compared to sum and mean. That being said, you can also specify these as keyword arguments. So instead of using this approach, you can also use this approach. Let me copy this. Let me paste here. Then the keyword argument name should be the column name, which is nothing but total underscore sales, then equal to, then the function, which is nothing but sum. Like that, you can specify as many keyword arguments as you want. The next one is nothing but average underscore sales, then equal to, then the value should be the function which you wanted to use. It is nothing but mean. Now let me run this. Even this one will work as per the expectations. Here, the total sales and average sales column names make it easier to interpret the results, especially when sharing insights with non-technical stakeholders. We can also apply different aggregations to multiple columns. Let's see how to calculate the minimum sale amount, maximum sale amount, and also number of commission percentage records based on sales status. So here we are going to perform 2 aggregations on sale amount and 1 aggregation on commission percentage. This is how the logic will be. So we should be able to say Toyota sales data dot group by sales status. Then to the ag, we can specify a dictionary as argument. The dictionary can have key value pairs where key is nothing but the column name on which you wanted to perform the aggregation. The value is nothing but the function which you wanted to use to perform the aggregation. As we have to pass a dict, we can only pass one function for each column. We cannot use multiple functions on each column. So in this case, with respect to sale amount, I should be able to come up with only either min or max or sum, but I can have as many columns as I want along with the functions. So here, let's redefine the problem statement. Let's come up with a minimum of sale amount based on sale amount column, and then get the count of commission percentage based on commission underscore PCT column. So here I should be able to say sale amount min followed by commission underscore PCT count. Now let me run this. You can see the details as per the expectations. Keep in mind, when it comes to the count, it will only count not null values. If there are nulls, it will be discarding those null values while performing the count. In addition to built-in functions like sum or mean, we can use custom aggregation functions as well. I'll walk you through the details about custom aggregation functions in the next lecture. For now, let's combine everything we have learned. Let's calculate the following metrics for each car model. They are nothing but total sale amount, average sale amount, the count of commission percentage, and also count of sales. The solution will be something like this. I should be able to say Toyota sales data, then group by car model, because we wanted to perform aggregation based on car model, then dot, then ag. Here I would like to rename the columns that are generated after performing the aggregations. Hence I'll be using a keyword arguments approach. So I should be able to say total underscore sales, then equal to, then you should be able to pass tuples like this. Sale underscore amount, then sum. So this is the column on which the aggregation function will be applied. The aggregation function that is going to be applied is nothing but sum. Like that, we should be able to define all the column names which we wanted to see. Average sales, again sale amount, then the function which you wanted to apply is nothing but mean. Then comes commission percentage count. Let me scroll down here. Then equal to, then commission percentage. Here I would like to apply count function. Then finally another count function to get sales count. Here I'll be using sale ID, which is unique, so that all the sales are counted without any gaps. Then the function which I wanted to use is nothing but count. Now let's run this and you can see the outcome as per the expectations. You can see total sales, average sales, commission percent count, and sales count based on car model. This combines multiple built-in functions and column-specific aggregations to produce a detailed summary of car model data. As part of this module, here is what we have covered. We have seen how to perform multiple aggregations simultaneously using ag. We have also seen how to rename aggregated columns for better clarity. Also, we have applied different aggregations to multiple columns. Even on a single column, we have seen how to apply multiple functions. For example, here on sale amount, we have applied both sum and mean in one shot. Now, it's your turn. Try this exercise. You should be able to group the data set by sales status. Then you should be able to calculate the total sale amount, the minimum sale amount, the count of commission percentage for each status. I hope you are able to come up with the solution for the exercise without much challenges. If yes, great job. In this lecture, you learned advanced techniques for aggregating data using ag function or method. In the next lecture, we'll explore how to come up with custom aggregate functions. Then we'll actually get into other aspects with respect to data transformations and processing using Pandas.